Good morning, everybody. Welcome. It is my pleasure to introduce you to Derek and Rob from JetBlue, who will tell us about their journey with real-time AI and ML with their digital twin using Databricks. So please, welcome.
Hey, hi, good morning, everyone. My name is Derek Olson. I'm the manager of data science operations at JetBlue. I'm excited to be here with Rob to talk with you a little bit about our AI and ML journey with Databricks. Before we dive in, though, just wanted to give everyone a chance to move around a little bit. So how many of you took a flight to be here today? All right. Thank you for your business. And how many of you experienced a delay with your travel? Okay. All right. Rob, remember, our closest exits may be behind us. So when you're experiencing the delay, though, it really isn't funny. It isn't a joke. And really, that's ultimately the goal that we set upon in this journey is how can we take the classic example of this week, which really represents a lot of the operational challenges that airlines face with airport constraints and airspace constraints, and how can we enable our decision makers to make better decisions and ultimately reduce delays and provide that better customer experience. So really, what if we can reduce that number of hands that was raised by half or even more? So this is what we want to talk with you about today and really give you that 32,000-foot view of how we've built this digital twin and platform and show you some of the components that we've used and really provide some of the design patterns if you're interested in doing something like this yourself. We'll take questions at the end and happy to open up the discussion further as well. So a little bit more about JetBlue. So our mission is to bring humanity back to air travel. So we really have this passionate focus on that customer experience. So that's for over 100,000 customers that rely on us every day on more than 1,000 flights, traveling on 288 aircraft. And each of those flights really touches the Northeast region. So we're New York's hometown airline. So all of those flights touch the most congested airspace in the world. When you look at aircraft volume, you look at customer volume, it's really incredible the airspace that we operate in, especially given those constraints, right? You might think that there's infinite capacity in the sky, but there's very significant constraints in airports in terms of gate space. There's even significant constraints with the routes that we fly, given the air traffic controllers that have to be responsible for a certain number of flights, which limits that throughput through certain air traffic regions. So really, this is a delicate balance of just-in-time manufacturing to get the aircraft, the crew, the customers all in the right place at the right time to successfully execute a flight. One of the hallmarks of JetBlue as well is really providing lowest possible price, really creating what we call that JetBlue effect of providing a better experience for a lower cost when we enter into markets to ultimately reduce that ticket price for customers. So we can't just have one aircraft operate one flight per day. It's just not economical to enable those low fares. So ultimately, one of our other constraints is ensuring that our most expensive resources, our crew, our aircraft, are utilized as much as possible. So that high utilization rate really provides a very slim margin of error for our operations. So using this week as a case study, right? Again, we have thunderstorms, which lead to delays and reduced capacity, which ultimately then cascades to additional delays in the system. So a lot of decision-making is handled by our System Operations Center. So 9 months before your flight, it's scheduled, it's put up for sale, and then the day before that flight is handed off to our System Operations Center, to execute on that schedule and mitigate any of those day of disruptions. So their decision making is really around what's that situational awareness of weather, ATC conditions. So that's a limitation. How do we provide that situational awareness to all of the different personas in the operating center? And how do we enable them to learn from the past, right? What were the similar conditions and outcomes from previous years? And ultimately, that's a lot of complex data that's changing very quickly. You can think of where is an aircraft, where is a crew, constantly changing, and weather forecasts as well. So how do we really enable individual users to understand that data, to identify potential risks? And also, how do we handle those cascading effects unique to an airline? Right, beginning of the day, if a flight's delayed, that's going to really cascade later into the evening and ultimately lead to disruptions that could take hours or days to solve. So this is what we really want to enable our System Operations Center to do, to proactively identify some of these bottlenecks and expand their situational awareness, understand the data that we have available, and understand how their decisions cascade in the network. So this is what we accomplished, or seeking to accomplish on our continual journey to build a digital twin and enable this proactive decision making. So really, this is utilizing the Lakehouse, an ML platform that we built in-house to build this operational decision-making platform. And we've been doing this just over the past year. And really, that wouldn't have been possible without some fundamental building blocks that Rob has built. So wanted to hand it over to him to explain how he's been able to accomplish us moving so quickly.
Thanks, Derek. You guys can hear me, right? Yeah, so digital twin. So I'm going to talk about some of the building blocks behind how we created this digital twin, right? So that reminds me of this famous quote, which goes something like, it takes a village to raise a digital twin, right? And that's certainly been our experience. It takes like a lot of different open source as well as proprietary technologies coming together to build something as complex as this. The first part of this digital twin infrastructure is our Lakehouse, right? And we're built on top of Azure Cloud. We leverage Databricks very heavily for both our data engineering pipelines as well as our machine learning platform. But there are certain technologies which make our version of the Lakehouse a little more different than other Lakehouses that you might have seen, this week. The first thing is we use Rockset for our document store as well as online store. And more recently, we're also using it as a vector DB. So it's a very underrated piece of technology. I suggest you guys check it out. We also use Tableau for all our business intelligence dashboards. There are a lot of applications deployed in our Azure Kubernetes as well. Front end, back end, a lot of endpoints as well. And we're partnering with Monte Carlo to build some of our data monitoring and alerting capabilities. And for our CI/CD processes, we're using GitHub Actions for most of CI/CD as well as version control. And I also wanted to point out a few of our philosophies as well as the constraints that led us to structuring our Lakehouse in this way. So at JetBlue, we're very focused on data governance and AI governance. We're very passionate about making sure that PII data is safe, your data is safe, right? And because of that, we have this system where data within different environments is absolutely segregated, right? So you're not going to see us moving data from a dev environment to a stage environment directly, so that's never going to happen. But the good thing is, the tools that, and features that Databricks have made available really allowed us to cater our Lakehouse to this kind of framework. We're using autoloaders, Databricks jobs, DLT pipelines, the whole thing to build our our pipelines, and we're like wholeheartedly committed to pipeline as code, which leads us to the medallion framework, right? So we're using this framework where the raw data lands in our bronze layer. After some transformations, it's promoted to a silver layer, and then the gold layer contains a curated set of like analytical data sets on top of which we can do advanced analytics or build machine learning models. But in order to orchestrate and make this entire system possible, we've had to invest heavily in robust CI/CD pipelines. And another cool thing about Databricks is the APIs, especially the jobs APIs, MLflow APIs, they integrate really well with a lot of platforms, in our case, GitHub Actions, and we're able to treat pipelines as any other piece of software where it's version controlled, it's tested, we can run unit tests, integration tests, and so on. So now that we have real-time data, right? So what are we doing with it? In the past 2 years or so, a lot of the data science teams within JetBlue have been creating some amazing AI-powered products. I'm going to list out a few. So for example, the commercial data science team has worked on this like amazing dynamic pricing engine. They're also doing a lot of work in terms of customer segmentation, personalization. The operations data science team, which is Derek's team, is working on this operational digital twin of the whole airline. The AI and ML engineering team is working on things like chatbots, LLM ops, ML ops, and so on. And there are also other teams within JetBlue, such as cybersecurity and revenue management, which is essentially pricing, working on anything from threat detection to solving like optimization problems. So in the past 2 years, we've really come a long way. And that trajectory is going to keep continuing, right? So with an eye towards the future, as we increase in terms of both the scale of models that we're creating, as well as the number of teams which might be building products, we wanted to make sure that we're laying a foundation for the future data scientists at our company who are building things in the future, right? So and because of that, we've created this product called BlueML. So BlueML is essentially JetBlue's in-house machine learning development as well as deployment platform. It's built on top of Azure as well as Databricks. It's a set of common libraries as well as configurations and a lot of other things. But the core reason behind us creating this BlueML is to make sure that our data scientists can rapidly iterate on models, worry about mostly like the core modeling part, feature engineering, and not have to worry about the deployment part. So you might be asking, right? So why? So Rob, like, why did you build BlueML? Why not, buy something out of the box or just use Databricks notebooks for everything, right? So it's definitely the hybrid approach, and the reason is because a lot of the problems that we have, it's very unique to JetBlue, unique to the airline industry, including our data as well as some of the deployment patterns we're using right now. So BlueML has really made us work within that framework. So first of all, like I mentioned, it's really allowed our data scientists to rapidly iterate on model and focus on the core modeling part, the things that they enjoy doing, right? And what BlueML does is just out of the box, it allows our data scientists to work with MLflow, abstract away some of the boilerplate code that exists in any kind of data science deployment, and also not have to worry about the configurations behind model tuning and explainability, that sort of thing. The other reason comes from more of a deployment point of view, right? So BlueML ensures that all our machine learning pipelines are standardized. So regardless of who trained a model, what kind of model it is, we can take it and then drop it either in a streaming inference or a batch inference, event-based, or drop it in Kubernetes. So that's all been made possible by BlueML. So it's not just like 1 or 2 people working on BlueML. It's available. It's like an open source tool within JetBlue, so anyone within JetBlue can contribute to it, right? We currently have up to like 6 contributors, 6 of our data scientists contributing to it, and that number is growing. Because of that, there's a lot of cross-pollination in terms of like knowledge and like techniques that you can get from data scientists working on one specific problem, translating to another problem. And one, I guess, like shocking thing we learned from that is data scientists can be very opinionated, and like we've found a great way to collaborate and work on something common that everyone can use. So ML in production, right? So we have data, we have efficient pipelines to train machine learning models, but what does machine learning look like in production at JetBlue? Because of BlueML, any kind of ML deployment can fit into one of these boxes, these 6 boxes. Generally, most of our machine learning deployments are inside Databricks, whether it's batch streaming, triggered ML serving, et cetera, right? There are also certain use cases where the model has to either live in a separate like Kubernetes cluster or embedded in some kind of application. And for situations like that, we're big fans of Flask, Streamlit, and like Angular for larger use cases at JetBlue. So this definitely makes the process of creating architecture documents easier because you can just copy-paste some of these things. And it also makes production a lot easier to maintain and replicate in the future. So we talked about the data, we talked about ML platform. The last piece of what goes into this like digital twin is language models and chatbots, right? So there's obviously been a lot of like talk of language models, a lot of development of language models in the past 6 to 12 months or so. And it's really made us rethink how people interact with data. In the past, in order to get a snapshot of, like for example, like our operations, right? You'd have to rely on a number of dashboards, number of views, but like that could potentially change with large language models and chatbots. So at JetBlue, we've currently deployed like 2 different chatbots internally to test whether this technology can scale, whether we can manage it, we can manage the life cycle, and use it in a very reliable way. The first use case is essentially document retrieval, right? So we have a lot of like documents such as crew member handbooks and a lot of internal FAQ documents that we've put in our vector database and essentially are querying. The other use case is a little more expansive. So this ties into the digital twin where our operational decision makers can use a chatbot instead of writing SQL queries to interact with the real-time status of operations or flights and so on. So Derek's going to talk a little more about that. But yeah, very interesting topic, right? And we're agnostic in terms of what kinds of language models we use. We're using LangChain to do most of our modeling, so the language models are pretty interchangeable for us. But at the moment, we're leveraging OpenAI as well as Dolly as 2 of the main language models in production. And this area is obviously involving and hoping to check out some of the new features that Databricks just added as well. But at the same time, so one of the key learnings that we've learned from this is building something from scratch, using LangChain. That's the easiest part. You can easily build a very small chain to do simple tasks, but ensuring that the model or the evaluation framework is set in place, the LLM ops framework is set in place, and the language model is getting the right context is the challenging part. So we're still working on improving that, and looking forward to using some of the tools that are being showcased at the summit as well. And yeah, so I think those are all the building blocks. And Derek, so this might be a mistake, right? Are we building a competitor for Twitter?
So this has been a year-long journey, right? So I sent a few messages to Jack. I'm thankful he borrowed the name. Ultimately, BlueSky is the name that we've given to our digital twin that we built on top of these building blocks. So really, this is how we can enable better decision-making by our SOC. So on those building blocks, we have a number of different data sets that we're ingesting into Lakehouse, right? You can think about all those different components that need to be in the right place at the right time, from customers to crew to aircraft. So all of these data sets are ingested in different cadences. So this is a mix of continuous streaming real-time sources. It's these external APIs that we're querying via DLTs and jobs. And all of that data is being built at an individual flight grain. So this creates that operations 360 data model with over 150 attributes for each individual flight. So we are operating 365 days a year in all different types of conditions, and we've been storing this data now for years. So we've been able to leverage that data to build the BlueSky models using BlueML and really create an ecosystem of models here. So we're building for an individual flight multiple models to better predict the different stages of flight to ultimately better understand a single flight in our network. So that's helpful to understand a single flight, but really the complexity of the airline is the incredible way that all of the different components are integrated and related to each other. So how do we manage those cascading effects? This is really the next layer in our digital twin is the cascade logic that seeds the initial state of our operation from those real-time and batch data feeds, and then runs inference on those models that we created, and then steps through time to rerun inference with those dynamic features as well as other static features to build out that 48-hour future window of the operation. So this really helps us identify when we will exceed certain throughput capacity constraints, when you can think of aircraft not being where they need to be or crews where they need to be. So what does this look like in Databricks? So this is really, again, building on BlueML that Rob touched on earlier. We have all this data ingested into Lakehouse, and we also have a traditional data warehouse. That data is then ingested into the core BlueSky models, which is made up of jobs and DLT pipelines within Databricks, which then trains these models and then are promoted and version controlled with MLflow. And then once those models are hosted, then we can run inference on the real-time data. After running inference, then we can run that cascade logic into the future, and then ultimately expose that for the downstream consumers so they can build out certain alerts that identify these risks in the future. So some of the other components that we're leveraging, of course, are data and model drift monitoring, which we're doing with Monte Carlo, and also integrating all of this into simulators. So this is really giving not only that future state of the operation given current conditions, but enabling simulating different decisions that our operations center might want to take to understand what is that effect on the overall network. Some of the other downstream consumers that we're using are web app and Angular, as well as the Blue AI chatbot, which I'm excited to share with you later on. So ultimately, this ecosystem with BlueSky is the core of our strategy. Let's solve the day of disruptions and then use this digital twin to work further back in the scheduling process. So really understanding how can we pull back that decision window to not just days, but months in advance to understand what is the risk given a certain schedule and modifying that schedule accordingly to provide the best customer experience. So the few of you raise your hands as possible when it comes to delays. So how do we make these insights actionable? So this is an example of the BlueSky app that we have that's one of the consumers of the digital twin. So this is where we build out that current state situational awareness. what are the current weather conditions at different stations? What are the real-time metrics of our operation to better understand utilization rates and on-time performance to identify the health of our network? And then on the other side, we have our alerts tab, which is really taking in that 48-hour prediction window to identify what are the alerts and categories of alerts that could affect the operation. Again, providing that better situational awareness for the teams. And the other capability enabled in this app is that simulation component. So being able to submit different scenarios, canceling, delaying flights, and understanding what is that effect on the entire operation to better understand as an individual the cascading effects that those decisions have. So web app is one way to interact, but most of our teams, of course, are working with chat and natural language. So really excited to employ the chatbot framework that Rob and his team created to build the chatbot, which really enables users, instead of having to query some database to get information on flights, can just, with simple prompts, what are the details of a particular flight, and then learn what are the scheduled values as well as the predicted values for that flight. So in this example, we have a flight that's delayed, which of course then begs the question, well, why are we predicting this flight to be delayed? So that explainability is one of the key components that is part of our pipeline. And so we can expose those explainability in the chatbot. This is delayed due to particular features in the pipeline. So some of the next steps for our journey, we want to continue to improve the different data sources that we're ingesting into the lakehouse. Also really excited to integrate feature store. And then for BlueSky, we want to continue to iterate on our chatbot. Really excited to delve more into graph representation of our network and graph optimization, as well as continue to improve on our ML ops, thinking of champion-challenger models, and continuing to use model drift to trigger our training pipelines. And Rob, what's next for BlueML?
Yeah, so very excited to be working on distributed deep learning. So that's something that's been on our radar for a while. Obviously, if we were able to create some kind of chatbot factory and embed it in BlueML, that'd be great as well. And also another thing we're planning to work on is better monitoring for our deployments, right? So right now, our monitoring framework is a little fragmented. We have Monte Carlo, we have alerts and monitoring through Databricks, but we want something out of the box for our data scientists so that they can track not just the drift of the model, but also the performance and reliability of the clusters which are in deployment. Yeah.
Thanks, Rob. So I do also want to call out the members of the Operation Data Science team who've made a lot of this possible, and some of whom are in the room today. So I want to call out Dr. Kola Ogansina, Jackson Bennett, Daniel Pesce, and Dimitri Kolomietz, who have all helped contribute to building this digital twin. And if you're interested in joining our team, we're hiring, so come solve fun, complex problems with us. Thank you.
Thank you.